But when insulin is high, it starts to have a signal on the fat cell. And that then brings us to the slow insulin resistance, where you have something happening in the fat tissue that begins to set the stage for insulin resistance in the entire body. And it takes longer to settle in, but it takes also longer to go away. That's why I call this one slow insulin resistance. Now, in the case of insulin, most people, so the key with the, yeah, I'll explain it this way first. So the most relevant feature with fat tissue contributing to insulin resistance is the size of each fat cell. When we typically think of fat, we would maybe say, okay, Steve has, I'll do this in kilos for the UK audience. Steve has 10 kilos of fat on your entire body. That's probably too much for you. Ben has 20 kilos. And yet, it's possible that I'm healthier metabolically than you. And that's because it's not the mass of fat that matters most. It's the size of the fat cell that matters. This is why women, despite universally being fatter than her male counterparts, are healthier with regards to insulin resistance and every single metabolic problem. It's because women, as a result of her particular sex hormones, have more fat cells, but they're smaller. So she has more fat, but smaller fat cells. And small fat cells are healthy, insulin-sensitive, anti-inflammatory fat cells. But the bigger the fat cell gets, the more it initiates a cascade of events or a series of events that creates insulin resistance.
And am I right in thinking we have the same amount of fat cells for our whole life pretty much?
That's a really, really safe assumption for most people. Yeah, for most people, a fat cell, sometimes students will hear that fat cells are immortal. That is not true. But they're long-lived. Fat cells will live about 10 years.